Hydroxy compounds and ethers. In this we are going to see the topic ethers. What are ethers? Ethers are a class of organic compound in which alkane, one of the hydrogen is replaced by or substituted by alkoxy group or aryloxy group. Alkyl group if present, alkoxy, aryloxy, benzene ring is present. Of the common formula CnH2n plus 2 plus O. CnH2n plus 2O. ROR. Here in the alkane, alkoxy group is substituted. Ethers classification: simple ethers, mixed ethers, oxygen atom on either side group. Simple ether on either side of the oxygen atom, similar groups are present are called simple ethers. On either side of the oxygen atom, different groups are present are called mixed ether. Dimethyl ether, diethyl ether, diphenyl ether. Similar groups are present. Otherwise, it is named as methoxymethane, ethoxyethane, phenoxybenzene. Mixed ethers, different groups present on either side of the oxygen atom are called mixed ether. Methyl methyl ether, methyl propyl ether, ethyl phenyl ether. Otherwise, methoxyethane, methoxypropane and phenoxyethane. So are called mixed ether, different group on either side of the oxygen atom, mixed ethers. Aliphatic ether and aromatic ether. If ether contains only alkyl group are called aliphatic ethers. Aromatic ethers means if ethers contains aryl group benzene ring in its structure are called aromatic ethers. So methyl dimethyl ether, methoxymethane, methyl propyl ether or 2-methoxypropane, 1, 2, 3 propane. In the second position, methoxy group is present. So 2-methoxypropane, aliphatic ether. Aromatic ether, diphenyl ether or phenoxybenzene. Phenoxy group is substituted in benzene, phenoxybenzene. Benzene, where methoxy group is substituted, is called methoxybenzene. So aryl group is present are called aromatic ethers. Methoxybenzene is called anisole. Next one is the structure of the functional group. Here central carbon oxygen atom, on either side carbon alkyl group is present. Alkyl group surrounded by hydrogen atom. Here the sp3 hybridized, sp3 hybridized, sp3 hybridized. Two carbon atom and making a bond with the sigma bond with the central oxygen atom. So sp3 all three sp3 hybridized, so sigma bond. Here due to the repulsive interaction between the two carbon atom, it's making a bond angle of 111 0.7 degree. Here the lone pair of electron present with the two sets of electron which is not involved in bonding on the heads of the oxygen atom. So structure of functional group in ether. Next one is how to name ether. So common name is dimethyl ether. IUPAC name is, so you got to take the second one is a main chain and the hydrogen is the prefix is a substituent. Methoxymethane. And here methyl iso, here the propane in the isomeric form. So methyl isopropyl ether, otherwise we can say it as 2-methoxypropane. And another one is tertiary. The carbon is tertiary in nature. Tertiary butyl methyl ether, otherwise 1, 2, 3 propane. The second position 2-methoxy 2-methylpropane. 2-methoxy 2-methylpropane is the name. Another one is methoxybenzene. Methoxy group is substituted in the benzene. Methoxybenzene or methyl phenyl ether. Next one is ethyl phenyl ether. Methyl phenyl ether. Methoxybenzene is called anisole. What is phenol is ethyl phenyl ether or ethoxybenzene is called phenol. Anisole and phenol. Methoxybenzene is anisole, ethoxybenzene is phenol. And diphenyl ether on either side of the oxygen atom, phenyl group is present is called diphenyl ether or phenoxybenzene. So the prefix as a substituent. The next one is heptyl group. By counting the number of carbon atom, heptyl phenyl ether, phenoxyheptane, isophentyl phenyl ether, 3-methyl 1-butoxy, 1-butoxy, 3-methyl butoxy benzene, and dimethyl glycolate 1,2-dimethoxy ethane, where 2-methoxy group is present called dimethoxy ethane. Oxy groups are present, 1,2-dimethoxy ethane. So this is the method of naming ethers. Next one is preparation of ether. First one is from dehydration of alcohol by using dehydrating agent sulfuric acid. Next one is from Williamson ether synthesis. The third one is from methylation of alcohol. Preparation of ethers by intermolecular dehydration of alcohol. 2 molecules of ethyl alcohol. Here one ethyl molecule and the another one ethyl alcohol molecule. From the 2 molecule, water molecule is removed. It forms, one water molecule is removed. It forms 2 CH2O and O joins to form diethyl ether. So here the 2 molecules of ethanol at the temperature of 443 Kelvin, the presence of concentrated sulfuric acid, it forms ethene. But the temperature carried out to 413 Kelvin, it forms ether. So the method is useful for the preparation of simple ether, not suitable for preparing mixed ether. 2 different alcohol is used, mixture of 2 different ethers will be found. They are difficult to separate. So similar type of ether, simple ether can be prepared by using the simple alcohol. If use the different alcohol, the product will be different. It is difficult to separate. So dehydration of alcohol, the presence of sulfuric acid at 413 Kelvin, alcohol dehydrated to form ether. Next one is Williamson ether synthesis. What is Williamson ether synthesis? Here the alkoxide, sodium hydroxide. Here the oxy group present along with the sodium like that of sodium hydroxide. Here the sodium alkoxide with alkyl halides in alcoholic solution of, so alcoholic solution on heating. Here the Na and Br reacts, and joins to form ethyl methyl ether. Here the sodium bromide is formed. Here how the reaction takes place is in the solution, sodium and bromine reacts on heating and the remaining joins to form CH3O and CH3C2. CH3C2 and CH3O joins to NaBr reacts. NaBr reacts and removed, and these 2 group joins to form ether. Methoxy. So here the methoxy group gets substituted instead of hydrogen, like that methoxy ethane. Here the reaction follows SN2 mechanism. SN2 mechanism or SN2 reaction. Here the first the formation of that intermediate results in the formation of the product. Here in the formation of here the tertiary and primary group. Now consider here it is the tertiary group, and one side of the oxygen, on another side of the oxygen methyl group is present. If we need this group of ethers, we have to take the primary alkyl halide group and tertiary alkoxide group. So Na and Br reacts, NaBr, and in that place methyl group gets substituted. Thereby we can get 2 here the propyl group, and 1, 2, 3. Common name is tertiary butyl and methyl phenyl ether. Here IUPAC name is 1, 2, 3. 1 propane. The second position 2-methyl, 2-methoxy propane. Here it is named. So here the ether. So tertiary group 1, 2, 3, 4. Sorry. Butyl group and the methyl group is present. So for example, instead of that alkoxide group, tertiary butyl alkoxide group, if we use that primary alkoxide, sodium methoxide, and tertiary butyl bromide, what happens is, here it is basic in nature. The alkoxide used is basic in nature. Thereby it undergoes beta elimination to form alkene. So CH3O reacts with H, it forms CH3OH, and Na and Br react NaBr. Here it undergoes beta elimination. Thereby results in the formation of alkene. 1, 2, 3. So 2-methyl propene. One propene is formed. So because of that basic nature, not even it's a nucleophile, it's also basic in nature. Thereby, by using primary alkoxide and tertiary butyl bromide, it forms alkene instead of that ether. So for the need of that corresponding ether, we have to use the correct reactant. Thereby, we can get the correct ether. So the next, so it's Williamson ether synthesis. These are all the explanation given. Reason out explanation is given. So Williamson ether is actually sodium alkoxide reacts with alkyl halide in the presence of the alcoholic solution. It forms ether. What are the ethers we need? Respectively, you have to take the reactant. So depending upon the reactant, the product will be different. Methylation of alcohol. So in methane, instead of one hydrogen, two nitrogen is present, is called diazomethane. So diazomethane, when reacts with ethyl alcohol, what happens is the nitrogen by using hydrofluoroboric acid, the nitrogen get eliminated. Here CH2 and H reacts, it forms CH3, CH2, OCH3. So nitrogen get eliminated and it forms ether, joins to form ether. So here how we can name is ethoxymethane or methoxyethane. Methyl, ethyl, methyl ether is formed. So the last method of preparation is methylation of alcohol. So preparation of ether from intramolecular dehydration of alcohol by using sulfuric acid at 413 Kelvin. Williamson ether synthesis, reaction of alkoxide with alkyl halide and heating in the presence of alcoholic solution. Methylation of alcohol in the presence of hydrofluoroboric acid at the temperature of on heating. The next one is chemical properties of ether. Chemical properties of ether. The two polar bonds are significant for the contribution of the lone pair of electrons, and dipole moment of ether is 1.182. Boiling point of ether is slightly higher than that of alkanes, lower than that of alcohol. The high boiling point of ether is due to it is miscible with the water molecule due to the polarity of the oxygen bond. While mixing with the water molecule, it forms extra hydrogen bonding. Thereby boiling point also higher when compared to alcohol, and it also miscible with water. The miscibility of ether with alcohol is due to the high electronegative oxygen making hydrogen bond with the water molecule. Due to the hydrogen bond, the boiling point also higher. The next one is nucleophilic substitution reactions of ether. Nucleophile gets substituted in ether. Ether, when reaction with the hydrogen iodide, the H goes to the ethyl group like this. So it forms ethyl alcohol. Iodine reacts, iodine joins with the methyl group, it forms methyl iodide and ethyl alcohol. Similarly with phenoxymethane, and here it also methylphenyl methoxybenzene, when it reacts, H reacts with the phenoxy group, it forming phenol. Iodine with the methyl group, it form iodomethane. So methoxybenzene, when reacts with hydrogen iodide, form methyl iodide and ethyl alcohol. Next one is auto-oxidation of ethers. Why ethers never be evaporated to dryness? What is the action of heat of ether? How ether peroxide formed from ether? Diethyl ether, on heating, it reacts with the excess of oxygen. It forms here diethyl ether, H2O2, like that of hydrogen peroxide. Here diethyl ether peroxide is formed, and also here it's another subproduct is diethyl ether peroxide. Instead of one oxygen, two oxygen is present, so it is called diethyl ether peroxide. So auto-oxidation of ether, ether on oxidation form diethyl ether peroxide, it explodes on heating. So ether never be evaporated to dryness due to it form the peroxide that is explosive in nature. Ether, when reacts with the phosphorus pentachloride, here the two ethyl group reacts with the chlorine, it form ethyl chloride. So the ethyl groups are halogenated to form ethyl chloride. Subproduct is phosphorus trichloride. Diethyl ether, on reaction with water in the presence of acid, two hydrogen. Here CH3CH2OH, one hydrogen, and CH3CH2H. It's formed 2 molecule of ethyl alcohol. So diethyl ether on hydrolysis form ethyl alcohol on dehydration form diethyl ether. With acetyl chloride in the presence of anhydrous zinc chloride, here what forms is ethyl group with the chlorine, it form ethyl chloride, the remaining CH3CH2 COCH3, it form an ester. So CH3COO CH2CH3, ethyl acetate is formed. And next one is when reaction with the chlorine in the presence of sunlight, all hydrogen group in the ether is replaced by or substituted by chlorine, it forms perchlorodiethyl ether. So in the presence of sunlight, the reaction with the chlorine, diethyl ether form perchlorodiethyl ether, all hydrogen in the ether is substituted by the chlorine. Next one is halogenation of the ether. Anisole. So anisole, methyl phenyl ether is called anisole. Here the electron denser benzene ring is present. So then electrophiles get substituted in the benzene ring. Electron denser benzene ring is called electrophilic substitution reaction of ether. So on halogenation is given. So halogenation, bromine in the presence of ethanoic acid. Here the anisole group, methoxy group activating the ortho and para position. So on bromination, halogenation, it forms orthobromoanisole and parabromoanisole. Here the parabromoanisole isomer is higher. Nitration, anisole on nitration with the concentrated sulfuric and nitric acid. Here also both ortho and para isomer is present. The para isomer percentage is higher than the ortho isomer. Orthonitroanisole, para-nitroanisole mixture is formed. This proportion is para isomer is higher. Next one is very important one, Friedel-Crafts alkylation and acylation of ether, aromatic ether, that is anisole. Anisole on alkylation, anisole on acetylation. Anisole in the presence of carbon disulfide and anhydrous aluminum chloride. Here the methylation, instead of one hydrogen and chlorine react, removed HCl. Instead of the two hydrogen, here the methyl group is substituted, it form. So 2-methyl, here how it is named is, this methyl benzene is called toluene. 2-methoxytoluene, here this one is 4-methoxytoluene. 2-methoxytoluene and 4-methoxytoluene is formed. Next one is with acylation, the presence of anhydrous aluminum chloride. Here acetyl group gets substituted. Here H and Cl reacts, removed as HCl. And instead of the hydrogen, H and Cl react, removed as HCl. So orthoisomer and para isomer. 2-methoxyacetophenone, aromatic ether, acetophenone. So aromatic ether, 2-methoxyacetophenone, minor product, and 4-methoxyacetophenone, major product. So Friedel-Crafts alkylation and acylation of anisole. Friedel-Crafts alkylation takes place in the anhydrous aluminum chloride and carbon disulfide as a catalyst. Here the orthoisomer and para isomer is formed. Here the name is 2-methoxytoluene and 4-methoxytoluene. Here anisole on acetylation by using acetyl chloride. Here what is formed is 2-methoxyacetophenone and 4-methoxyacetophenone is formed. Uses of ether, use of diethyl ether. Diethyl ether used as a surgical anesthetic agent in surgery. It is a good solvent for organic reactions and extraction, and it is also used as a volatile starting fluid for diesel and gasoline engines. It is used as a refrigerant. These are all the use of diethyl ether or aliphatic ether. What are the use of aliphatic ether? So like that, if it is asked, means you have to write this, diethyl ether or use of aliphatic ether. Next one is use of anisole or aromatic ether. Anisole, methoxybenzene is called anisole, is used as a synthesis of perfumes and insecticide pheromones, and it is also used as a pharmaceutical agent. These are all the use of anisole. Subscribe for more videos. Thank you.